All right. So today we want to see some of the changes that happened to Canvas since yesterday when it wasn't working, and today where it's, I don't want to say working, but it's working more than it was yesterday. So there's that. I started removing some of the broken links as I update to the new version of Wiley Plus. So you still want to use the modules as your home base. This is the first place that you want to go, is modules. Whenever you want to find out what's going on in the class, this is where you'll go look for new things. So the first module is the calculus typo. It says calculus 3, but it's the calculus 1 visitor information center. And it's got various pages that you can click through about how to get you to use Canvas, about how to use Wiley, and so on. There's a quick introduction, so you can introduce yourself to your classmates, and then there's some practice assignments on Wiley Plus. Where I want to get into the bigger changes is in the modules connected to each of the chapters. So rather than having 2 entries in each module for discussing section 1.1 and then a separate homework section, all you have to do for 1.1 is click on section 1.1 homework, and then that will bring you to this page where it has a copy of the book. So you can open up the, here it comes, eventually. Open up a copy of the textbook to the section that is relevant. Before I had to link to the whole book and you had to scroll through it, but here you will just have, it'll go right to the section that's relevant. And then you can go through, you can do some of the examples. You can read this like a textbook. You could read this like a regular math textbook, which means you'll probably ignore it, but that's fine. Then there's also videos for the examples. And so you can watch the videos for some extra examples that I might not have done in class. And then there's also an interactive activity where you can play around with making some equations of lines. So then after you read the e-textbook, watch the videos, and do the interactive exploration for a little bit, then you go on to do the problems. And then the problems, for some reason, you have to sit on the ground with your laptop on, I think you have to levitate it. It looks like it's either sitting on something invisible, or maybe you just have to levitate the book there. Seems really uncomfortable, but apparently that's part of it. You just click on open, and that'll bring you to the section 1 homework, and then click on start assignment. And then you can start doing the problems. One thing to note, I set the problems to give you an unlimited number of attempts. It seems kind of silly to do that on like a multiple choice problem, because you could just click through until you get the right answer. So let's see, it is definitely not this one. So when you submit an answer, it'll highlight in red, say, no, that's wrong. And then so you have to actually go through and figure out what the answer is. Oh no, that's not right either. I should actually look to see. It moves the things around, the answers around a lot. There we go. And then once you get a problem correct, you can go on to the next problem with the arrows. Some of the problems will have you fill things in. So interpret the statement f of 5 equals 5. When the car is 5 years old, it is worth $5,000. Oh, they don't want you to use commas. And so on. So once you've submitted all your answers, highlights and it'll highlight in red anything that is incorrect about your answers. So once you've submitted all your answers, it'll tell you that you got 5 out of 5 on the section 1 homework. And then you can go back and see how much time you spent on each one, what your score is, and so forth. So that's for each section of the book. Going down to next, we'll take you to section 1.2, and you see the same setup. Exponential functions from the text, that'll be the textbook. and then a couple of videos with examples. And then you can scroll down, hover your laptop, and sit on the floor and do your homework assignments. All right. So like I said yesterday, I have due dates, but if you miss the due date, you can still go in and submit your homework. But the due date for these first 4 assignments that have been assigned is August 29th. And that's a lot of time to get through these problems. More assignments will show up before then. You don't want to save your assignments to do them all on the due date. All right. Stop there. Any questions about the ongoing additions to Canvas that I'm fixing? Cool. So go to the home page or the modules, and that's where new assignments will show up. So if you look back and you see, did I do homework 1.3? Is that new or not? If you don't remember, you're probably not doing homework often enough. So pay more attention to what you're doing. You know what I mean? So that's always a fun question. It's like, oh, did we do this problem yesterday? Like, oh, I don't know. Did we? So with that in mind, I want to talk about our topic for today. Let's switch over to the board and see what our problem is. There, we got some focus. So here's our first problem that I want to use just for a quick warm up. I want you to find the slope of the line between the points -1, 3 and 0, 5. So take a moment and find the slope between these 2 points. Here, give you some. There we go. Is it playing? All right, so we want to find the slope of the line connecting the point -1, 3 and 0, 5. What we know is that slope is rise over run. That's the R&R definition of the slope. The slope is rise over run. We're actually summing up 2 things in the one number that we call slope. The rise is how much y is changing, and the x is how much x is changing. So the change in y we can write as 5 minus 3, and then the change in x will be 0 minus a -1. 5 minus 3 is 2, 0 minus a -1 is 1, so we'll say the slope is 2. Now here I said we start off at -1, 3 and end up at 0, 5. If we went in the other direction, then we would be fine. So if we had set up 3 minus 5, then we would have written -1 minus 0, and we'd had -2 over -1, and that would still be 2. That's the great thing about linear functions. They have a nice constant rate of change. The slope is always the same. Any questions on finding the slope of the line? Great. So The reason that I bring this up is that one of the things that we wanted, one of the things that we marked as a big question of calculus is, what is the equation of a line tangent to a function? So one of the big questions of calculus is find the equation of the line tangent to a function at a given point. Find the equation of the line tangent to a curve at a given point. So this we decided, well, you didn't really decide, I kind of decided for you. This we marked as one of the big questions of calculus. One of the things that we want to know is what's the slope of the line tangent to a curve at a given point. Here's the issue that we run into. The line tangent to a curve only hits the curve in one spot. So line tangent to the curve only intersects the curve at one point. The line tangent to the curve only intersects the curve at one point. But we need 2 points to calculate a slope. Otherwise, we just end up with 0 over 0. So the line tangent to a curve only intersects the curve at one point, but we need 2 points to calculate the slope. We have to have a change in y and a change in x. If we try to do this with 1 point, we end up with 0 over 0. So if I try to just use -1, 3 and -1, 3, this is no good because if I calculate delta y over delta x, neither one of these is changing. Oops. 3 minus 3 over -1 minus -1. And that is undefined. So we can't calculate slope with 1 point, but we still want to know the slope of this tangent line. So here's what we're going to do. We're going to do the classic math thing. We're going to approximate. We need 2 points, so we'll just pick 2 points that are close together. So our solution / workaround maybe more of a workaround than a solution. Pick 2 points on the curve that are close together. So our solution to this, or our workaround, is we're going to pick 2 points on the curve that are close together. Brings up an important question. How close? As close as we need to find the information as we want. So that's the important parts. How close? We'll make sure that they're as close as necessary to get the information that we want. Then the question comes, how will we know that we're close enough? And the answer is, don't worry about it. After 1,000 problems, you'll just know. That's the intuition that we're trying to build in this whole process. We're trying to get to the point where you'll just know. It's like when you were learning to drive, if you've learned to drive, those of you who have learned to drive, you know that you have to turn the wheel to make the car go right. And then that raises a question, how much do we turn the wheel? And the answer is, don't worry about how much you're turning the wheel, you'll know. So we don't say, well, we need to make a 90-degree turn and the radius of the turn needs to be 10 feet. So we need to turn the wheel to 45 degrees if our forward movement is 6 miles per hour. We don't want to do all those calculations. You just turn the wheel enough until you know that the car will go where you want it to. We're just trying to build an intuition here. So let's take a look at an example problem with an actual function. Let's find the equation of the line. Tangent to the graph of the curve f of x equals 4 minus x squared when
hey, Professor,
x is equal
can
to
you move the
negative
camera down a little bit?
No, but I can move the paper up.
Sounds good.
So let's find the equation of the line tangent to the curve f of x equals 4 minus x squared when x equals -1. So we have a point when x is equal to -1. Let's finish out the point. Oh, let's first take stock of what we need. We want to find the equation of a line. So that means we need two things. We need a point and a slope. So to find the equation of a line, we need two things. A point and the slope. A line consists of only two pieces of information, a place to start and a direction to go. A point, that's the place to start, and a slope, that's the direction to go. We got half a point already. We got x equals -1. So let's find the other half of the point. So we have x equals -1. If we just plug that into our function, we'll now have a complete point, 1, 3. To find a slope, we need to have 2 points. We need 2 points to calculate the slope, and we've only got 1. We got the point where the line will intersect the curve, but we need 2 points to find the slope. Otherwise, we have 0 over 0. If we're doing calculations, we divide by 0. The math cops come and break down our door, end up on the show Math Cops. That one got canceled a lot earlier than regular cops got canceled. I don't know if any of you remembers. You might be too young, but Math Cops, what you gonna do? What you gonna do when you divide by 2? And then there's like a whole thing. It wasn't a very popular show. I think I'm the only one who watched it. It may have taken place entirely in my head. I'm not sure. So we need 2 points to find the slope. We have a point where x is equal to -1. We're going to pick a point that's close to -1. So I'm going to turn the page since I conveniently ran myself out of space. So let's choose points close to -1, 3. And then calculate the slope. So I've got x equals -1. That's one of the points. So let's try a point x equals -1.1. And we'll calculate the slope. We'll do -1.1 squared minus a -1 squared. We'll look at the difference in the y's, and we'll divide by the difference in the x's. Oh, it's not 1.1 squared, is it? I didn't use just the square function. We'll plug 4 minus -1.1 squared minus 4 minus -1 squared over -1.1 minus a -1. So I got the top is going to be 4 minus a -1.1 squared minus, I'm just going to write 4 minus negative, this is just going to be 3. And then we'll divide by -1.1 minus -1. And then we'll see if I got my parentheses right. And we get a 2.1. So I picked a point that was close to -1, 3. And I calculated a slope of 2.1. So let's suppose that we wanted to pick something closer to -1. We know this is an approximation of the slope, where we're with a delta x of 0.1. So here we have our delta x down here. So let's try a point that's closer to x equals -1. And let's calculate the slope there. So we'll have 4 minus -1.01 squared minus, I'm just going to replace that with 3. And we'll do -1.01 minus a -1. So I'm going to redo this calculation and insert a 0. And we get a slope of 2.01. So now we started off with a point that's even closer to the point -1, 3, and we got a 2.01. So the reason I have 4 minus -1.01 squared is that my function from the previous page was 4 minus x squared. So we're just plugging -1.101 into the function 4 minus x squared. The 3 comes from plugging -1 into the function 4 minus x squared, And so it's always going to be 3. It's this first point, the first value that we're changing. So we see when we went to negative 1.01, we got a slope of 2.01. And then we can continue. Maybe we're not convinced yet that the slope is going to be 2. So I'm going to drop in some more zeros. I'm going to do that off camera. Type in here, and we get 2.001. So partially, I know that this is headed towards 2 because it's my problem after all. I should know where it's headed. But what we're trying to do is build an instinct. So we see that when x gets closer to -1, the slope appears to be getting closer to 2. That's what we want to observe about what's going on here. As x gets closer to -1, the slope seems to get closer to 2.
Where did the 3 come from?
3 is just what happens when we plug -1 into the function 4 minus x squared. I'm evaluating the function at -1.1 and evaluating the function at -1 and calculating the slope between those 2 points.
Then why did you subtract it?
Because I'm looking at the change in y divided by the change in x. So the change in y, will be the function evaluated at -1.1 minus the function evaluated at -1.
Oh, okay. So it's a stand-in.
Yeah. So the function that we're looking at in this example is 4 minus x squared. We're trying to find the equation of the line tangent at the point -1, but we have to pick points that are close to -1 so that we can calculate slope. So there's an actual change in y and a change in x, so we don't get 0 over 0. And then the change in x is just a -1.1 minus a -1. So we're looking at the change in y and the change in x, so we subtract the 2 values. y2 minus y1 over x2 minus x1. Change in y over change in x, that's rise over run. So this is coming from values that are smaller than -1. This is values coming x approaching -1 from the left. What happens if x approaches -1 from the other side, from the right? So let's look at what happens when x approaches -1 from the other side. Let's look at a value of x that's close to -1, but bigger than -1. So like x equals -0.9. We'll calculate the slope by doing the change in y divided by the change in x. We plug -0.9 into the function, so I get 4 minus -0.9 squared. Then I subtract the value of the function at -1, which we know is 3. And then we divide by the change in x, which is going to be -0.9 minus the -1, which is what we're aiming for.
I'm sorry. Can you repeat how you got negative 0.9?
I just picked it. I need to pick something that's close to -1.
Okay.
So I just picked negative 0.9. So I go to my calculation. I'll do negative 0.9. And I get a slope of 1.9. And we're going to see the same thing happen when I pick points that are closer to -1 on the other side. So when x is negative 0.99, we'll calculate the slope. And we'll get a slope of 1.99. And similarly, if we calculate the slope when x equals negative 0.999, and so the same thing is happening on this side of -1. As x gets closer to -1, m seems to get closer to 2. Remember, the reason that we have to do this is that we're trying to calculate a slope, but calculating a slope means change in y divided by change in x, which means we need 2 points. We can't do this with 1 point. If we try to do this with 1 point, we get 0 over 0. So we take the point that we care about, -1, 3, and we pick points that are close to -1, 3. So maybe I should have made a table of values. The point that we're concerned with is in the middle here at -1, 3. And I'm just picking points that are close to -1, 3. So negative 0.999. And then negative 1.01. And then negative 0.9. And then negative 1.1. And we're seeing what happens when the 2 points that we pick are getting closer to the point -1, 3. What kind of a slope do we get between those 2 points? Any questions?
Professor.
Yes.
So what are we trying to prove if, like, when we calculate the slope, like from the left and from the right?
We're not trying to prove anything. We're plugging in numbers. We're never going to prove anything by plugging in numbers. We're just trying to get an idea about what the slope should be. So these numbers, since the slope seems to get closer to 2 as x gets closer to -1, these calculations suggest that the slope of the tangent line should be 2. So based on these calculations, we think the slope of the tangent line should be 2. So based on these calculations, we think the slope of the line tangent to 4 minus x squared at x equals -1 is 2. So if we check that out, if we look at the graph of 4 minus x squared, And then we put in the equation of the line through the point -1, 3 with a slope of 2. So there's a line that goes through the point -1, 3 with a slope of 2. We can see that they'll intersect at just one spot. So if I trace over to -1, you'll see that -1, 3 is the same on both graphs. But if I move off, then the values are slightly different. Because one's the line, the other one's the parabola. So the line and the parabola intersect at only one point. Another good place to see this happen is the better graphing calculator. So let's take a look at this on the better graphing calculator. So this is Desmos.com. This is a way better graphing calculator than your graphing calculator is going to be, mostly because it's a lot more intuitive. If we want to look at the function y equals 4 minus x squared, depending on where we want to look, we could just use things that are familiar, like zooming in and out. If we click and drag, we can look at different parts of the graph instead of going in and typing a window with text. So we can also, it's also easier to change the colors of our graph. So our equation of the line was y equals 3 plus 2 times x minus a -1. And we can see, now we can see easily that it's easier to find the points where the graphs intersect. We just click on where it looks like they intersect. They only intersect at -1, 3, and if we zoom in, we can see they still only intersect at -1, 3. Any questions? Desmos is the best.
What happens if you put in bigger numbers?
Bigger numbers bigger than -1.
Yeah, like one
So-
or
That would get us, actually, let's find out. Go back to the calculator.
would you get the same numbers?
Well, we wouldn't. Let's turn this one off and let's build, let's say y equals 3. Oh, I'd have to calculate the slope separately. If we pick a point that's farther away, I can't remember how to do it in Desmos. If we pick a point that's farther away than -1, that's the wrong direction. We don't want to go there. That's picking a point that's further away from -1. And I want to find the equation of the tangent line. I want to pick points that are close together. So if I pick a point on the graph, pick points on the graph that are far away. Like if I take this point and this point, that's not close to the tangent line. What I want to do is pick points that are very close to the point when x is equal to -1, so that I can get a close approximation of the tangent line. So conveniently, I did not give myself enough space. We got to turn the page. So our calculations have suggested that the slope of the line should be +2. So we have a point -1, 3, and a slope of 2. So I just use the point slope equation of a line y equals y0 plus m times x minus x naught for my equation of a tangent line. Then I just have to plug in the point -1, 3 and the slope of 2. So y0 is 3 plus the slope, which is 2, times x minus x naught, which is -1. So here's the equation of a line through the point -1, 3 with a slope of 2. As some of you have pointed out, this slope has a y-intercept of 5. If I just multiply all this out, here we have in b plus mx form. And what I was using was the point slope form. I picked point slope form because the point that I was interested in is not the y-intercept. I was not interested in what was going on when x is 0. I was interested in what's going on when x is -1. So I just went with point slope form because it has the point that I care about. Questions? Now, if you wrote 2x plus 5, that's perfectly acceptable. That's how we typically indoctrinate students. I mean, that's how we typically train students or let's see, educate students to write the equation of a line. We typically write it in mx plus b. I think that's really weird. That's telling you what direction to go before saying where you should start. I prefer to say start off at 5 and add 2 a bunch of times. That's how I prefer to read lines. That's what this equation says. Start with 5 and add 2 a bunch of times. Repeated addition is summarized with multiplication. That's why we have 2 times x. X is the bunch of times. Start off at 5 and add 2 a bunch of times. Start at 5. Oh, I usually say green for that. I should say y starts at 5 and y increases by 2 every unit. I think for the most part, by the time you get to calculus, students tend to be very good at the mechanics of algebra, but not really the thinking behind algebra and arithmetic. I suppose you could interpret what I just said as me saying that y'all aren't very good at algebra. But that's because I'm speculating that y'all aren't very good at algebra. I'm not blaming you for that. That's the way we trained you. We don't set up a system for you to understand algebra. We set up a system for you to grind out thousands of problems. And it's hard to change because it's kind of easy to do that. Meanwhile, algebra kind of should have been, hey, remember arithmetic? We're just going to do that again. So the big idea here that we want to get across today was that we wanted to make a calculation that we really couldn't make. We didn't know, we don't know how to find the slope of a line with just one point. So we chose points that were close to the point that we're concerned with, and then just chose closer points until we got an idea about what the slope should be. We approximated, and then we improved our approximation. And that is the calculus strategy. Approximate, then improve the approximation. approximate, then improve your approximation until you get the information that you want. Now that's the practical side of where to stop until you get the information that you want. But what we really want to do is we want to improve our approximation infinitely. What happens if we pick a point that is infinitely close to -1? And then, so that it means we need to understand what infinity is. We need to start understanding how infinity works. Typically, we like to think that we understand how infinity works, but then we keep using it like a number, and that demonstrates that we clearly do not understand how infinity works. Plus, Buzz Lightyear, I thought astronauts were supposed to be good at math, and Buzz Lightyear is like, oh, to infinity and beyond. It's like, oh, dude, beyond infinity is just more infinity. So you could just say to infinity. But I guess astronauts in the, I can't remember what they're called. In Buzz Lightyear's organization, I guess the astronauts don't need to be very good at math. Space Rangers, thank you. I should know, I've been to Disneyland, I've been a Space Ranger. Any questions? How's everybody, okay? So this represents kind of a big idea that doesn't really show up until we get to chapter 1.7, the idea of a limit. Limits are how we're going to do things like plug in infinity. Limits are how we're going to do things like divide by 0. So in this particular problem that we did, we could interpret this case of 0 divided by 0 as being equal to 2. We're totally not going to do that because the math cops just come bursting right through that door. I mean, I have my degree, so I can just pull out my math cop badge. It's like, oh, look, guys, I am approved to say things like 0 divided by 0 is 2 in this case. But then they'll be like, oh, well, you can't do that in front of all those students because they are not approved. They do not have clearance to say things like 0 divided by 0 is 2 in this case. So you got to watch out. Those math cops play hardball. You know what I mean? All right. So tomorrow we're going to continue looking at this idea of a limit. We're going to look at it in more rigorous terms because this is a math class, and as important as intuitive ideas are, there's still rigorous calculation that needs to go along with it. So that's going to do it for today. Tomorrow, today is Thursday. I forgot this in the previous class too. Today is Thursday, so we don't have an actual class tomorrow. Tomorrow is just going to be for office hours. So if you have questions about some of the homework or what you need to do, send me an email. And if we can't sort anything out in the email, you'd like a face-to-face meeting, then I can send you my Zoom information and we'll set up a time and you can drop in for office hours. Any questions? Classes Monday, Tuesday, Wednesday, and Thursday. So I'm going to run class 4 days a week. It became a little bit too grindy to run it 5 days a week, and there was lots of burnout. So I decided this semester to try 3-day weekends and see if that helps a little bit.
Thanks, Professor.
All right, that's going to do it for today. Everybody have a good weekend. I will see you on Monday, and thanks for playing.
Thank you.
Thanks,
Thank you
Professor.
very much.
Thank you.
Thank you.
Thank you.